Hey everyone, my name is Bartek Castelli and welcome to the second episode of TUNERD Adventures hosted by HTG Tuning. So this time we're in Cyprus. We're on the Achne track right now and we're visiting our Cyprus customers. We have 3 cars to tune this time. One E30 for the drift, S15 for the drift and a Time Attack Miata. It's a beautiful weather out here, warm, we'll have a new challenges to face, so I hope guys you'll enjoy. This episode will be very technical. Actually we're recording this intro after we've done everything, so you'll be witnessing a lot of technical stuff, issues that you may face, so guys stay tuned with us. For those who are watching us for the first time, we're very happy to see you here. For the ones that's returning, stay tuned for more. Cheers! Since the last time, quite a lot of strategies changed in the GCU. Some were introduced new, like the drive-by-wire mod, some new tables and stuff. So because this car has been done good 2 or 3 years ago, I need to basically revise what's going on. For sure calibrate a electronic throttle, so GCU can modify position when doing the upshifts, when doing the downshifts. So basically the cuts and blips, right? So before we hit the road and before we start driving the car, we just need to check everything, make an update, make sure everything works good, works fine, pass the adaptations, and then we'll be ready to go on track and tune it fully on the track. So this car has a Link ECU and the GCU controlling a 7-speed long ratio DCT, sequential shifter and paddles here. So it's a racing setup, pretty easy to use I guess. So let's do all of the checks and then we'll be ready to go. DPS is already calibrated. Drive-by-wire raw input, which is a pedal reading input, calibrated. Now we need to calibrate analog outputs because it streams the analog output to the Link ECU as a drive-by-wire modifier A and B outputs. Link does not like full 5-volt signal, so we need to limit it a tiny bit. So yes, we'll do a little range scaling and it should be good. Okay, so we are checking the wiring because for, typical tuning reasons some wiring broke and it stopped working. Now we have signal working, so it's all good. We have the fixed paddles working, good. We have signal, one down, both. Yes, okay. It's good. The resistor broke. Okay, so basically there are some pull-up resistors in the wiring which give us the ability to measure different voltage for different actions, and one of them broke, so it is what it is, it happens, so we're going to fix it now and we'll be ready to go for a short test. Okay, so we have a shifter fixed, everything's working now, so we're going to calibrate some tables for the torque reduction, and we'll be ready to go. Oh, it's okay, so we have the gears working, everything's calibrated. Just checking the dash to display the gear. We have paddles working, full selection, everything's good, taking us smoothly. So just final checks and we'll go on from that. Let's head out to the next car, get it prepared, get it checked, because our plan is to check all 3 cars before we go to the race racetrack where we'll do the actual tuning. So here again, check up the wiring, check the scaling, check the ECU settings, check the GCU settings, fix the wiring. So managed to do a couple of things. Yeah, let's head to the next car. Next car will be a BMW E30 if I'm correct, if not then S15. So yeah, but it's so hot here. Oh god, the Cyprus is really hot place, but I really enjoy it. So yeah. So we arrived at the second location. We're going to check the BMW car right now, and yeah, let's see what it is. This one?
Not this one.
Not this one.
Then I do white.
Okay. Full stop. Okay, so the car had the issue with moving. So initially I thought it's a oil level issue, but then we've checked that it has a clutch by wire assigned, that it's not scaled properly. So we tried to move with a 80% of a clutch pressure drop. As you can see, pedal not pressed is scaled at 80%. So basically very simple reason why we had the issue, you know, taking up. So what we need to do is to scale a clutch by wire position so it's not dropping the pressure. Anyways, we have the rear of the car lifted, so we're going to check the oil. It's better to be safe. I have also done a valve test. Valve test is a procedure where we check the outputs, how GCU, how the valves work, solenoids, so it controls all of them. You can see on the diagram that we have all of the valves. The baseline is it's not super perfect, but it's good enough to drive. We have very little of a backfeed. It's probably because GCU is lying loose around other wires, but it's going to be mounted right now on the firewall, solid, so it won't move, it won't play with the other wires. So far so good. Calibrating a clutch by wire, then we're going to fill the oil to the top as a pre-check for the track, and we'll be good to go. So going back to the official firmware via the suite loader, and we'll be good to go. Now we have seen the full range of a clutch by wire pedal, so we need to just scale it properly and then assign it as a function. What the issue is that when GCU engages the solenoids, it draws power. So when there is not enough power capability to be delivered to the solenoids, we run into a situation called a backfeed. So the valve, when it tries to open, it turns on, let's say, the other valves. So in this case, we're running into issue where fork positions are trying to be controlled. So when GCU tries to put the gear in, there is not enough power. It can be caused by either a ground issue or power supply issue, and it causes the other valves to turn in a little bit by the backfeed. So in this case, a clutch pressure is being built up by tiny bits, so the clutch is engaged, and we have the GCU struggles to put the gear fork into the position. So it has a drag, it cannot freely engage and disengage the gears, and it creates the whole issue that we're facing right now. So the guys need to check, I basically checked the relay that GCU is connected to, and the wires connected to the relay, they are really hot. It means that we do have some issue, because the thickness, it looks like a 1.5 square millimeter, so it's pretty okay, I guess. But we're going to check the grounds, we're going to check the power supply lines, and yeah, basically we're going to see if it fixes it. You can clearly see it in the log. Let me show you. Because you see this line, this here, this blue.
Yes.
This is a clutch pressure. So look, we start to move the forks right now to center it, because that's the beginning of the adaptation. Let me turn off the unused ones. We have a link RPM, okay, so the engine is idling. We start to center the forks to be able to go into the adaptation. So as soon as it tries to center them, the clutch turns on by tiny bits.
Yes.
So it's like in manual, when you have a foot on not on the clutch, it's not disengaged. You cannot very easily put it out, because it's pulling. It's basically engaged. So this is the issue that we're facing, and let me upload a valve test firmware, because the first one that I've made, as I said to the camera, I thought it would be acceptable, but it was far from perfect. We made a valve test again when the transmission is hot to see the result. And listen, this is a example on our webpage how valve test, how it should look like. So this is a control signal, this is a result of a draw. So as you can see, the baseline, when they are off, it's perfect. So when one valve turns on, none other basically responds. So this is only one response. But here, if you take a look, this baseline it's not a straight line. So as you can see, I have highlighted one of the solenoids, and this is responsible for one of the clutches. So as you can see, when some valves turn on, sometimes it drops, it goes higher. So we run into an issue where, for example, when one of the clutches wants to get powered on, it turns on some other valve responsible for other functions. And so basically the transmission behavior is not as expected. This line is not flat. Some valves respond better, some are, horrible, like this one. So what we need to do is we need to check the wiring, because otherwise, if the wiring is not done properly, it does not work properly, we'll be basically facing issue after an issue after an issue. So that's the first thing to check. So basically, after playing a little bit with the wiring, we managed to get a tiny bit better result. It's good enough to get it driving. So we're going to take it to the track. We'll test it on the track. We'll try to tune it. If there will be things that we do not like, we'll get it onto the workshop tonight. We'll inspect the wiring. We'll check the mechatronics, how it's done. We'll basically inspect the transmission, but just not to waste more time now. We're going to test if it rolls here. If it's all fine, we're going to head to the track now, where we have the other car waiting for us to be checked and so on. But we have 2 days, so let's make it wise. So far it looks not tragic, so let's see how it does on the track. But guys, this is very important to always check the wiring, always check the valve test, because this simple inspection gives basically the idea if GCU can operate, because GCU operates strictly on the data. So when it sees the values, it operates based on those values. When it sees the wrong values, because of any reason, it will work bad. So it's very good to do all hardware check, wiring check, configuration check, to basically check everything. First issue, we had a clutch-by-wire configured wrong. Then we managed to find some backfeed issues. So always check step by step everything. Yes. So you have Multec?
Yeah.
Okay. So
M150.
All right. So I'll jump inside. I'll check the calibration of everything. Scaling and stuff, and we'll go on from there. Okay, so first thing, to check the baseline where we are. Also, sequential shifter. Interesting thing that this is a drift car. We have a paddles here. Also HTG paddles with the carbon plates. But anyways, let's do all of the calibration updates and stuff, and we'll go on from there. Okay, so I'm going to do the very first drive to see how it takes up and how it goes. Where are you going from? So we have a base done. I'll go head to the track right now, driving normally just to see our baseline, and then we'll swap with the drivers. He'll be driving, drifting, and I'll be adjusting. But for now, it's just easier for me to do the baseline by myself, so I'm going to head to the track and drive normally. So, I made a first drive with the car, everything seems fine. We have the cuts working, we have the blips working. So yeah, seems pretty good, seems pretty soft right now. So driver is right now going to drive. I'll just do some fine tuning with a full boost here on the track and then we go drifting. Okay, so guys, if you want to see something interesting, we stopped. Everything seemed fine until we went to really big pressures, and in this case we run into oil starvation issue. So there is not enough oil in the transmission. So what it means, basically, when we go up the RPM, up the totally big pressure, it's just not there. So top line is a clutch pressure graph. The middle plot, red line is the RPM, and the blue line is torque. So as you can see, we were accelerating, going into a boost zone, into a torque zone. As the RPM were rising, the clutch pressure started to drop, even though in the tables it has been commanded to go up and up. And in some points, we run into these oscillations. Basically, this is how the oil starvation looks like. So the transmission needs oil, but it has not enough. So the pressure rises, drops, as it can get the oil from the sun. And when it cannot, it drops. So basically we have to refill the transmission now, add more oil so we can maintain the high pressure that this car needs. So a little pause for now. Probably we're going to go with the Miata in the meantime. Tuning of basic tune of the Miata. I drove one time on track and it seems good, so yeah, let's do the mapping and then track. Check the fuel level, maybe it's the fuel.
You have oil pressure.
Yeah, everything so far looks
good. From outside it looks good.
Yeah.
I don't know how the...
It's good. I will just make it, smoother and smoother, because this is a light car, so with a quick shift it gets upset.
Yes, and the small engine that revs high and...
Anyway, so far it looks...
Take your time. Take it easy.
last run. Last run. Starting from the start, throttle on the maximum.
Yes.
We are on gear. What is it? We started on the second gear. Yes, we're here on the second gear. You're hitting the upshift for the pre-selected gear number 3. We are on the gear number 3. You clutch kick, right? Pressure goes to 0.
Third gear?
Yes, third gear, yes. So clutch kick on gear number 3.
And then I
We
put
go
fourth.
full. Yes, you pulled 4th, and here is 4th.
It had a delay on my.
So I'll tell you how much delay is it exactly.
If I know there will be a delay, I will never try to push it again. So if I know in my mind that there will be a delay, it's okay.
Okay. And on gear number 4 you hit downshift on full throttle, but it was above 7,000 RPM, so the limit did not allow us. So my suggestion is to switch the limits off. The protection for the overall, because
What is the aftermath?
what is the aftermath?
If
If you drive 7,000 RPM, you make a mistake on normal driving, not drifting, you'll over-rev the engine. There is no safety feature that works and does not work at the same time, so one way or another. In manual transmission, you don't have the over-rev protection. If you hit the downshift,
if now imagine this track now, I am coming on the wall and I am fourth gear. But when I am coming on the wall, I am full speed, and then I clutch and handbrake and third gear. So
Because right now you are not on the clutch, you are fully on the throttle. So pre-selections is okay. I have 100%.
if I slow the car with the gear in, it's a different thing. So if I am coming forward
It is different.
and I am trying to make the car stop on the sand, like whoa, with the gear in, I want it, after when I push the throttle, I want the head to be inside, so I can go. That's what I'm doing. I'm coming.
First of all, turn the safety feature off.
We can put it on again afterwards. We can try one more time.
When you're driving manual transmission, you don't have the pre-select, you don't have the override protection. Because when you're drifting, you still have like, what is it, like 7,800 more or less here, I guess, RPM. You're 800 over the limit. So you press downshift, it says no, override protection, I want it. So you have a pre-selection up to very low load, then you have no pre-selection. So you'll be in the middle. It is quicker to go from middle to this rather than go from bad pre-selection to neutral pre-selection to better pre-selection.
One more thing to do. Remove me 5th, 7 and 5th.
Okay, so we are using which gear max?
4th max.
4. Okay, 4 max.
Because if I sometimes push it, it won't go to 5th.
Okay. So on gear number...
να μην μείνετε.
Αντιβάλλει, ναι, να.
Να κάνεις τώρα πάλι τέτοιο.
Εγώ τι, ποιο είναι από εκεί.
But do you use second gear again? No. Do you
Άνοιξε μόνο κεντρικό.
do you on the track at any point downshift from third to second?
No.
So only second for the start and 3. Okay, this is easy.
There are no two identical drivers. Each one of us uses slightly different techniques, has different habits and surely individual preferences. Beauty of standalone control is flexibility, and flexibility makes it possible to have your setup entirely yours. As a tuner, my job is to understand what driver needs, distinguish needs from wants, help understand the system, and sometimes points towards new options. It's a challenge, as every tune is different, but this is what my job is, and I do love it.
switch just to
My,
Keep the fan on.
my suggestion is, because you're guys from Cyprus,
Yeah.
it's hot here,
Yeah.
so a bit. Get a water heat exchanger.
Water heat exchanger.
So don't use radiator, use a heat exchanger for water. Like
Why not the thermo switch with a fan?
What's how much heat? How much heat can air take? No, sorry. What is the amount of energy you need to spend to warm up the temperature, to warm up the air? What is the amount of energy you need to warm up the water?
Okay.
So it will be way more stable. This is why all of the new cars, the OEMs, they
have charge
don't use radiators at all. They have only one radiator for whole water cooling system. Okay, so Mazda is done. A little tricky tune, but it's fine. It's ready. Exhausting. Okay, so a couple of issues that we had today. So let's start with the S15. S15 owner used to have a short ratio DCT box, which has a very, narrow gear ratio step down. And right now this is a long ratio. So with the long ratio, each upshift drops RPM more and more. What it means, when on track, when you're drifting and you're upshifting, in this case from 3 to 4, you have quite a significant RPM drop. And engine struggles a lot with this ratio. So for tomorrow's test, they're going to change a ratio, final drive ratio, because they have a Winters differential, so it's pretty easy to adjust. I basically adjusted the pre-selection also to fit this track. Same situation like we did last week at the Ferropolis, so to use only the gears that are necessary for the track. And other than this, S15 has been pretty much straightforward, even though it required pretty good precision. Miata, on the other hand, it had a couple of issues. So first of all, we had the wrong CAN bus scaling. The CAN configuration has been done 2 or 3 years ago. And while I was applying load, it was pretty good on the middle load, but high loads, I couldn't get any clutch pressure. It was like dropping. The torque reading has been dropping very low, so it turned out to be really silly and stupid issue. CAN bus message for the map sensor, which is used for torque calculation, has been 1 byte length, so the maximum that it could stream was like 255, and the boost of Meta is higher than this. So as soon as we reached 1.5 bar of boost, it was like dropping down and reading again from 0. So as soon as we fixed the stream message length to 2 bytes instead of 1, we got a pretty good, map sensor calculation. Torque calculations, everything worked like a charm from this point, but the car has a little issue of a gear 4 centering fog, so it's not coming as quickly to the neutral position as we would like it to be. So sometimes the downshift was a little delayed. So I also managed to fix it with the pre-selection settings. Right now, if you're driving on the gear number 4, the pre-selection on 5 happens at really high RPM. If you really are on a high RPM zone, going to the 5 gear. Otherwise, we keep in neutral pre-selection, so the next 3 pre-selection is really quick. It took some time to figure it out what's happening, a couple of logs to do and analyze, but other than this, I've been driving this car for a good half an hour non-stop on the track. The driver took over the car and went for another 10-15 minutes of driving. Temperatures are a little high, but steady. Transca is around 130 degrees. We're in Cyprus, as I mentioned before. It's hot today. Now it's sun's so it's nearly over, so it's pretty good heat. But it's hot, so it's worth also mentioning that it would be good to swap from regular radiator to some heat exchanger, because the amount of heat that water needs to heat up, the amount of heat that water can get from the transmission oil is, you know, way bigger. So in hot countries, definitely heat exchanger, maybe combined with a radiator. But anyways, it was stable enough to give us no big issues for today. Owners enjoy it, but don't ask me about this, let's talk with them directly. So I'm Bartek, nice to meet you again. What's your name?
Alexis Harris.
Okay,
Nice to
and
meet you.
this is your car.
S15 2JZ with DCT HTD gearbox,
Okay.
top spec.
So you run here in Cyprus Drift
Yeah.
Series. So
And so then maybe next year I will run Drift Masters.
maybe next year Drift Masters?
yeah.
Alright, so fingers crossed, we would like to see you there. So how long do you drift?
1 year and a half.
1 year and a half from the very beginning of the drifting?
Yeah, yeah.
So for 1 year and a half you drive really good.
Yeah. I used to have an SR20,
That's a 20, yes.
but it was very low horsepower car and I couldn't catch up with the big boys. So I upgraded to 2J with DCT and it's trying to catch the big guy. Now I am third in the championship.
Okay,
So whoever wins the next weekend takes the championship of the top 4.
okay, that's nice. So overall, how do you find the combination of a automatic transmission in a drift car?
The first thing that I wanted on the car was a DCT because I had an F80 M3 and I used to drift on the streets with that car,
Yes.
without clutch, without handbrake, without nothing. And that's why I wanted DCT on my drift car because it's neutral for me to drift with the.
So far happy with the choice, with the decision?
Yeah, very happy. We need to learn adapt. Yeah, you need to adapt. Me adapt with the car.
Okay, so previously you had a DCT but with a short ratio, and right now this is a long ratio.
Yeah.
So do you feel the difference?
It's a different car. Every time you change ratio, it is a different car. You don't know what to expect with different ratios, with different gearbox. I believe the best gearbox is the 8,
Yes.
not the 135.
Yes. So this is the one that you have on the car
Yeah,
right now.
it's the
So
best.
right now you have also a winter's differential, so you can adjust the. So overall today I think we made quite a lot of adjustments.
Next time you will come back again in Cyprus.
Yes. But I'm very happy. If you're happy,
Yeah, I'm happy. Yeah.
that's good. I'm happy as well. So we see you tomorrow.
Tomorrow again, parking.
Yeah, we'll
And maybe 6 months you will make my Supra. DCT.
Okay. And next year we see you on the Drift Masters.
Yeah.
All
hope
right.
so.
Thank you
Thanks,
very
man.
much. Okay, so day one is nearly finished for today. So we finished tuning 2 of the cars, Miata with the DCT and a turbo engine for the racing, for the time attack, and the S15 with the JZ engine, also DCT long ratio box. So we're on the Cyprus. It's really hot today. can see it clearly on the transmission temperature, so it's really tricky to get a very good, smooth and quick and reliable tune. Those were two tricky tunings to to make, but we managed to do it. Owners are enjoying the cars pretty much. We've done quite a lot of runs. We're driving all day. Right now we're heading to some other workshop to finish working on the E30, which had a little issues earlier on today with some backfeed, with some transmission related stuff, so we're going to investigate it now. But we can call it a day here at the track. Tomorrow we'll come here again and do some more testing, probably with the BMW if we manage to fix it for tonight. Maybe the guys will join us for tomorrow, but overall we're very, very happy. I am happy. I enjoyed those. We had pretty good fun and runs here, so I hope you guys also enjoyed this. Discussing our group. Works pretty good.